Welcome to my presentation to team up ProxySQL and Orchestrator to work together. So let's start with some introductions first. So my name is Matthias Crauwels. I live in Ghent in Belgium. I'm a bachelor in computer science. I've been using Linux as a user and an administrator for about 20 years. I was for a PHP developer for about 10 years. And in this position, I became the one responsible for our MySQL backend, and thus evolved to be the MySQL DBA. So I'm a DBA for about 8 years, and it's my third year at Pythian. So currently I'm a lead database consultant in one of the MySQL teams for Pythian, which means that I'm the technical team lead for the team, and that I try to make my colleagues learn the right things and help them with architectures, and I am their escalation point when they get into trouble. And my escalation point is Peter, sitting here first row. So, and I also have a kid. You can see us there in a fairy tale park where the trees have eyes. So. Just a little bit about Pythian. So we're a global IT company. We started off as an Oracle consulting company, and then evolved to do much more things. Okay, so we do managed services, database services, Oracle, MySQL, MS SQL, MySQL, Cassandra, Mongo, you name it. We do cloud migrations and operations. We have a kick-ass analytics as a service system, and we do then the cool guys in Pythian do some AI, machine learning, blockchain. So those are the cool kids all the time. But yeah, so for today, this is what I will be presenting. So let me first recap a bit from my presentation last year, where I was talking about Orchestrator and ProxySQL. So then we'll have some default behavior for both applications. We'll go some deeper into Orchestrator Hooks, and then we'll decouple communication between both. So let's get started. So my slides from last year at this conference, they are online on SpeakerDeck. If you do SpeakerDeck-mcrowell, you'll see all my presentations there. The one from last year is in there. So my title last year was Implementing Database as a Service using Open Source Tools, which were basically Orchestrator and ProxySQL. So let's recap a bit. ProxySQL, what is it? It's a layer 7 proxy application for MySQL. It's intelligent load balancing. It understands MySQL traffic, so it speaks the MySQL protocol. You can set it in between your application and your database. It knows about underlying database topologies, and it knows whether instances are up and down. So it can make intelligent calls based on that. And it can shield your application from the complexity of the underlying database structure. So Jean-Francois was talking this morning about replication. Simon was also. You have a single master, you have multiple slaves. If you put ProxySQL in there, you can hide that complexity from your application and reconfigure your traffic through the proxy. So this is the first typical setup that we do for ProxySQL. So you have your application servers, you have your database servers. They are divided in different host groups, which is something that ProxySQL introduced as a concept. So there can be one or more servers in a host group, and you put ProxySQL in between. So in this example, ProxySQL is its own layer. You can scale this up as you want, and you can just load balance like you would load balance an HTTP server, because ProxySQL will send all the writes to the right server and all the reads to the reader nodes. I have recently published a blog post on blog.pythian.com about how we did this auto-scaling group with ProxySQL in Google Cloud Platform. So if you're interested in that, go check out the blog. But the other very common approach is to put your ProxySQL instances on the application servers. So in this case, your application talks to localhost for ProxySQL, and your proxy will connect to the databases. This works. You can even cluster the proxy servers to work together and share configuration. Keep in mind that this will cause also overhead if you have a large number of application servers, because they will start checksumming and they will start fighting with each other, and that might be a problem. I've been talking to a few guys here on the conference that had issues with that, so be careful. if that is something that you fear, then a dedicated proxy layer like this might be a better solution. You have less proxies to configure and to run than in this case. But this is also a very common approach. The other application that we use, that we talked about last year, was Orchestrator. And Orchestrator is a high availability and replication management tool. So what it does, it is an application that starts discovering your servers, your MySQL servers. It discovers your entire topology. As soon as it knows one server, so it connects to one server, it runs show slave host, show process list. Do I have any masters? Do I have any slaves? And it will try to connect to all the servers it can crawl. And it will discover everything in your topology. That's the first thing that it will do. The second thing is you have a web UI. You can view your topology in a very convenient way. There were some screenshots in presentation this morning. I don't think I added a screenshot in this case. No, I didn't. But it's a very nice overview of all your servers. And the advantage of the web UI is that you can also use it to make changes to the topology. But you can also, like, if you say only RDBAs can make changes, but the developers can view everything, that's also possible. You have a read-only view, you have an admin view. And then the cool thing is that Orchestrator can do refactoring of the topology. So that is, whenever you decide you need a change in the topology, you need to move a slave to a different master, you need to move an entire block of servers with an intermediate master and some slaves behind it to be replicating from somewhere else, you can just drag and drop. There's an API where you can use JSON commands to do refactoring, and there's a command line client where you can do the same kind of things. But obviously doing it in the web UI is more fancy, and you can see immediately what happens. And then the last thing is whenever Orchestrator detects a failure, and both Jean-François and Simon also talked about that, failure detection is hard. So Orchestrator is connected to all your servers, and it will start collecting information from all the different nodes. So if one server reports like, hey, I'm not replicating, it will start looking at other nodes in that topology, and it will try to reach a consensus to know whether it's down or not. And then you can configure it to automatically recover. So if it's a master that goes down and all the slaves behind it are saying, hey, I cannot reach my master, Orchestrator will declare that server as failed, and it will promote a new master if there's one available, and it will hook up the old slaves back to that new master, and your topology will be fixed. Obviously, there's a few things there. So this is the high-level topology that I presented last year. So you have your applications, you have a cluster of ProxySQLs that connect to one or more replication topologies, and then you have your Orchestrator nodes managing the replication. Orchestrator itself is made to be high available. This is communicating to Raft, and there's one leader node elected, and the leader node is the one making changes. These are the dark arrows, and the light arrows are just the Orchestrator nodes pulling the same information to know about everything, but only the leader will make changes. So let's talk about the default behavior of this setup. So ProxySQL has a feature called read-only flag monitoring, and to turn it on, you have to define a MySQL replication host group. And a MySQL replication host group has two important fields. It has a writer host group and a reader host group. So what ProxySQL will start doing then, there's a monitoring user that connects to all the nodes that you configured, all the servers that you configure, and it will start checking the read-only flag of that specific server. And when the server is read-only 0, so it's writable, it will put the server in the writer host group. And if it's detecting a read-only true, so the server is not writable, it will put the server in the reader host group. This is the only requirement to have this is that you have your monitoring user configured correctly, that it can run show select at read-only. That's the only thing needed. So with some basic user, without any specific privileges, that will work.
Does it screen if more than 2 nodes are
No,
writable?
no. It will just take all the writable nodes in the writer host group and all the readable. So that's the problem that we'll be getting to. Then you put Orchestrator to apply promotion, apply MySQL promotion after master failover. The configuration settings in Orchestrator have somewhat long names. Yes, so Orchestrator, in this case, Orchestrator will flip the read-only flag when it does a master failover. So by default, this was false in versions lower than 3.0.12. And since 3.0.12, it's been true as default, which is a good thing. So in this case, whenever a master failure is detected and a promotion is done, Orchestrator will toggle the read-only flag for the new master, and it will try to toggle the read-only flag for the old master. But as you know, your master has failed, so it might not be able to reach that server. So it might not be able to toggle that flag. So that's one of the problems. So if your server has crashed and it's down, and you start it up again, have your default configuration set to bring up the server read-only, maybe to have it bring up skip slave start so it doesn't start replicating, but it becomes read-only. The problem obviously is when it didn't crash, when it just got partitioned. So yes. What if the network partitions? So the orchestrator sees the master being unavailable, and it cannot. It promotes a new one, but the old one is still writable. Orchestrator cannot toggle it. ProxySQL will move the new master to the writable group, so the writer group, and it will place the old master as shunt because it's likely also not able to reach this one. So, but when the partition gets resolved, it will still be writable, and ProxySQL will say, hey, this is writable, so I will put it back in the writer group, and it will get write traffic, so you have split brain. So you're writing to 2 different nodes, so that's not good. Yes. So solutions to prevent this: stun it, shoot the other node in the head. So if you have that option, like if you're running in a cloud environment, you run your cloud API command to kill that other node to make sure that it dies and that it doesn't come back writable. Obviously, that's not always possible, so there's still the possibility. You can also run a ProxySQL scheduler script that deletes any shunt writer nodes from the configuration, but you have to delete it from both reader and writer groups. Yes, yes, obviously, that is a big problem. So if you only delete it from the writer group, that's not going to do anything because it will already be out of there. But if you don't delete it from the reader group, then it will see, oh, this is writable, so I will put it back in the writer group automatically. So that's a problem. So Orchestrator, to go back to that one, has a few hooks that we can use. Yes! So Orchestrator implements hooks in various stages of the recovery process. And hooks are like events that are called whenever Orchestrator does something. So, and you can configure your own scripts to run it. Orchestrator is developed by Shlomi in GitHub, previously at Booking, before that at Outbrain, and they all have different requirements. The one maybe wants to move a VIB, the other one maybe wants to reconfigure a proxy. You name it. So to do that, you can just write your own scripts. So this makes Orchestrator highly customizable and scriptable. And there's a default configuration for each hook. It's a bit naive. That will echo some text to temp recovery log. Obviously, when you reboot your Orchestrator node, temp will be empty and you will not have anything. So if nothing else, use these hooks to alert you, to script something, to log something to a table, to a file that is not temp, so you can know what's happening. That's first tip. There's a very simple script that I once wrote. Yes, to like post a message to Slack. This is just a small bash script. It's like 10 lines or something. You give it a message and it posts your text to Slack. So very useful, and then Orchestrator will notify you when something goes wrong. Okay. So which hooks are there? So the first one is one of the most important ones, is the failure detection. So Orchestrator runs failure detection, and you cannot disable that. As soon as you configure Orchestrator and you load one server into it, it will start discovering, and it will start running failure detection. What does that mean? It will try to detect failures, but it will not do anything yet with it. So the only thing it does in this case is it says detected a failure type with a cluster name, number of replicas affected. So if you put that message to Slack, then you already know, oh, something is wrong. Next, there's pre-recovery hooks. Obviously, these are called pre-recovery. So whenever you have a graceful takeover or a failover process, a graceful failover takeover means that you run a command to say, I want a new master in this topology, even there's no failure detected. You can do that in Orchestrator, and that's a graceful takeover. Or you have a pre-failover process. That's when Orchestrator detects failure, and it will run a reconfiguration. And so you can take different actions in this one. One of the actions that you might want to take is to make sure that this server never gets writable anymore, that you're failing over. Post-recovery hooks is then whenever you have done the failover, and then you have, again, failover and graceful takeover, and then you have an event when it's unsuccessful, when the failover didn't succeed, and then you have different processes for when you have a master failover or an intermediate master failover. So those are very useful differences, because if your primary master fails, you want probably to do something else than when an intermediate master fails. And then there's some environment variables that you can use in your script. So the first one is the failure type. So what do we have? Do we have a dead master? Do we have a dead co-master? Do we have an unreachable master? Like, we don't know what it is. If it's that, it's something else. If we have lagging replicas, if we have a dead intermediate master, etc., etc. Then you will have the Orchestrator failed host, failed port, the cluster name, and the cluster alias, cluster domain, number of replicas, and whether it's downtimed or not. These are all variables. Oh yeah, come on. Then you also have some variables to see if there's an automated recovery for masters and intermediate masters. The local hook Orchestrator host that is running this this hook, whether it's successful, the number of lost replicas, etc. And then the last one is useful, the command that was run to maybe make a difference in your actions. So if you want to do a different action in graceful or force master failover, so that's possible. And then if the recovery was successful, you will also have access to the successor host name, port name, and the alias for that node. So that's also useful for scripting. The Orchestrator magic tokens, they are basically the same, but the previous ones, they were the environment variables, and these are like parameters that you can put in the commands that you can parameterize your scripts. I personally prefer these ones over the environment variables, but that's the way you write your scripts or write the things you do. The full list of all options is available in the documentation, so go ahead and read those. So why Instead of relying on ProxySQL's monitoring of the read-only flags, you can start pushing changes to any other applications like ProxySQL. So like in pre-failover, you want to remove the failed host from the writer host group. Post-failover, if the recovery was successful, you want to put the successor host in the writer host group. You can do all kinds of things. You can move VIPs, you can move other stuff. If you have access to DNS records, you can update DNS records. You can do basically anything you can script. But test before enabling this in production. Because if you put this automated and something happens in the middle of the night and you didn't test enough, then you can end up with a scenario that Jean-François described, where you have suddenly a master somewhere else and a slave somewhere else, and obviously that's not the case.
We have Orchestrator probably fail over on a daily basis between 5 and 10 servers, because we have scheduled network maintenance and we don't do anything to prevent masters or intermediate masters being handled.
Yeah.
And so Orchestrator just kicks in, and then we know that the process works because.
Yeah.
But to be fair, we have had to evolve some of our failure and the hooks to make all the edge cases be clean enough to be acceptable for us.
Yeah.
So
Sure.
the testing is important, and the problem is that even when you think you fixed it, you will find other edge cases which you hadn't anticipated in the past.
Yeah. Exactly. Okay, so let's decouple communication. Orchestrator hooks are great, but what happens if there's no communication possible between your orchestrator node and your ProxySQL, if the network there is gone? So that's also a problem. The hooks are fired once. What do you do when you cannot reach ProxySQL? Do you stop the failover and stay down? You need at least to have the admin credentials available in your orchestrator nodes. So that's also something of a security risk, because you're updating ProxySQL over the network with admin credentials. So if you 100% trust your network, okay, fine, but it's still something to consider. So the solution, we decouple Orchestrator and ProxySQL, and we put Consul in between as a key value store. So Orchestrator has built-in support to update master coordinates in a key value store. It has support for both Zookeeper and Consul. We went for Consul because it's very lightweight and very easy to configure. And so this is how you configure it in Orchestrator. These are the settings you do. You give it a master prefix. So any cluster master coordinates will be MySQL/master/cluster name and then the host name for this particular master. You give it the Consul address. In many of our implementations, we put the Consul nodes on the Orchestrator nodes because they're both very lightweight. And we have 3 Orchestrator nodes for a high availability Raft cluster. And so for Consul, that's the same kind of setup. So we can just rule out any network failure between Orchestrator and Consul. So we just update the local Consul server. But obviously there's Zookeeper where you can put multiple servers that you can update. So that just works. So which keys and values does Orchestrator push to Consul? So this is literally copy from the Orchestrator manual, by the way. If your cluster alias is my cluster and your master host name is some host, then your key will be MySQL master my cluster, and the value will be your host name. Additionally, you can have them separated by host name, port, IPv4, IPv6, like you want, where each time the value is added to the key value store, and that happens automatically as soon as you configure it. So as I said earlier, recommended setup for Orchestrator is to run 3 nodes with their own local data store. That can be either MySQL or SQLite. And you have communication between them using the Raft protocol. I was talking to Simon this morning, and Booking, they're not using Raft yet because they don't know if it will fall over with the amount of servers they have, but it's to be tested. But I don't think many people will run thousands of servers, so should be fine. This is also the preferred setup, 3 nodes for Consul. So we install the Consul server on each of the Orchestrator nodes. Consul comes with an agent, so we can let Orchestrator just talk to the local Consul, and Consul will update the data in the cluster, and it distributes to the 3 nodes using the Raft protocol. So there will be always a leader node. The agent is configured with the 3 IP addresses for the server nodes, so it will find out which is the master node. It will push the updates there, and by default, we have then a HA solution. We have avoided network partitioning because a majority vote is required to be the leader on both applications. So if one of your nodes gets partitioned, it will not be the Consul leader, but it also will not be the Orchestrator leader. And optional, Orchestrator extends the Raft protocol to yield for a specific node to be the leader. So we could easily implement a cron job that selects the Consul leader and yields the Orchestrator node to have the leadership in the same node. So you don't have to negotiate where to write. But what about slaves? Orchestrator cares about masters. Orchestrator doesn't really care about slaves. They are there, and Orchestrator will pull them, but it will not do any. It will not publish them anywhere. It will not do anything there. So therefore, we have the API. So Orchestrator comes with a HTTP API where you can just scroll anything that's in the Orchestrator database. And with a fairly simple script, it's if the simplest version that I've written for this is like 10 lines. It just scrolls each cluster, all the servers for the clusters. Whenever it's not a master, it's a slave, and then we put it in the MySQL slaves section in Consul. And whenever something changes or when the server goes unreachable, we can update Consul by removing this node or by changing the IP address or the port name or anything like we want. And so now everything is in Consul that we need to know. So we have our masters in Consul, we have our slaves in Consul, and now we need something on the ProxySQL side to read that data. So we install the Consul agent on all the ProxySQL servers, and they are just clients, so they don't store any data, but they join the cluster, so they know that they can query everything that's in the Consul cluster. And so now we can have a little script to configure ProxySQL. So first option is just a script. We can run a cron job, or we can put something in the ProxySQL scheduler that crawls the key value store and that updates the ProxySQL configuration. Pro, it's fairly easy. Just go through anything that's in the Consul key value store. It's fairly quick. If you use the ProxySQL scheduler, it works on a millisecond base, so you can run this every millisecond if you want. But the negative side I found in this was it wastes a lot of CPU cycles, because if you were querying every 100 milliseconds all the values in Consul, that's a bit overkill. So what we came up with is to use Consul template. Consul template is an application or an extension for Consul that's also written and supported by HashiCorp, the creators of Consul, and it registers as a listener to Consul values. So every time a value that you have requested from your template, it will, every time that value changes, it will regenerate the templated file. So in this case, this is an example template that Ivan once wrote. So in this case, we're working with test cluster. So it gets the master host name for test cluster. It deletes anything in our writer host group. In this case, we have writer host group 0. And it will replace the values we have in the configuration file. And then for the MySQL slave tree, it will just loop through them all in the entire range, and it will replace them in host group 1, which is our reader host group, with key and value for host name. And so then we load them to runtime, save them to disk, and our ProxySQL is reconfigured only each time whenever a value changes in Consul, so whenever Orchestrator or our slave script has created an update. And so this is the overall architecture that we end up with in that case. So we have ProxySQL, we have them clustered. So what we share between both of them is users, host groups, but what we do not share is MySQL servers, because Consul template will update MySQL servers. And we have Orchestrator and Consul running on the same machine, both communicating on their own Rafts protocol. So they're not sharing the sharing connections, but they are just they each have their own Raft protocol going on, and they share the data. And in between, there's the MySQL layer that we are managing in this case. So okay.